Today, in this video, we will see numerical on member subjected to uniaxial loading. Numerical is a steel rod 6 meter long and 40 in diameter is subjected to an axial tensile force of 1000 kN. Find the change in length, diameter and volume of the rod. Take E is equal to 2 into 10 raised to 5 Newton per mm square and Poisson's ratio is equal to 0.25. Data: length is equal to 6 meter, 6000 mm. Axial tensile force P is equal to 1000 kilonewton. 1000 into 10 raised to 3 Newton. Young's modulus 2 into 10 raised to 5 Newton per mm square. Poisson's ratio mu is equal to 0.25. Diameter of steel rod 40 mm. We have to find change in length denoted as delta L, change in diameter delta D, and change in volume. First, calculate change in length. For change in length calculation, get help of Young's modulus formula. Young's modulus is E is equal to stress upon strain. Stress is load upon area and strain is change in length to the original length. P L upon A delta L. Change in length is equal to PL upon A. Change in length is equal to axial tensile force multiplied by original length of that steel bar divided by area of that steel bar and Young's modulus of that steel bar. With the help of Young's modulus formula, we get change in length formula, and P is 1000 into 10 raised to 3 Newton. L length is 6000 mm. Divided by area of that steel rod of diameter D 40 mm is pi by 4 into D square. Diameter is 40 square. Multiply by E Young's modulus 2 into 10 raised to 5. 1000 into 10 raised to 3 into 6000 upon pi by 4 into 40 square into 2 into 10 raised to 5, 23.87 mm. Change in length for that 40 mm diameter steel rod is 23.87 mm. Next, calculate change in diameter. Delta D. For calculation of change in diameter, we have to get help lateral strain formula. And lateral strain is ED. Lateral strain is change in diameter to the original diameter. For this circular bar, this along the axis is linear strain and perpendicular to the axis is lateral strain. Change in diameter is equal to strain in lateral direction multiplied by original diameter D. Equation 1. D is 40 mm and change in diameter. We have to calculate change in diameter, change in strain in lateral direction. For calculation of ED, strain in lateral direction, we have to get help of Poisson's ratio. Mu is equal to lateral strain to the linear strain, and lateral strain is strain in lateral direction ED and linear strain is EL. Therefore, ED is equal to Poisson's ratio into EL. Poisson's ratio is 0.25 into EL, strain in longitudinal direction, is change in length to the original length. Change in length is 23.87. In step 1, we calculate it. Divided by L, length of that steel rod, 6000 mm. 0.25 into 23.87 divided by 6000. Lateral direction strain comes 9.95 into 10 raised to minus 4. And our main objective of step 2 is to find change in diameter. Therefore, change in diameter is equal to, put this ED in equation 1, 9.95 into 10 raised to minus 4 multiplied by diameter of that steel rod is 40 mm. So change in diameter comes 9.95 into 10 raised to minus 4 into 40 is 0.0398 mm. For calculation of this change in diameter, we have to get help of strain in diameter, strain in lateral direction. Strain in lateral direction is change in diameter to the original diameter. From this equation, change in diameter is strain in lateral direction multiplied by original diameter of that steel rod, and in this equation we need strain in lateral direction. So finding strain in lateral direction, we get help of Poisson's ratio. Poisson's ratio is equal to lateral strain to the longitudinal strain. And from this Poisson's ratio equation, we find lateral strain. Lateral strain is equal to Poisson's ratio into longitudinal strain. Then lateral strain is 9.95 into 10 raised to minus 4. And therefore, change in diameter is equal to 0.0398 mm. Next, calculate change in volume. Formula for calculation of change in volume is strain in longitudinal direction into 1 minus 2 into Poisson's ratio multiplied by volume. Strain in longitudinal direction, this change in length upon original length, 23.87 upon 6000. Change in length upon original length into 1 minus 2 mu into volume. Change in length is 23.87 divided by original length is 6000 into 1 minus 2 into Poisson's ratio is 0.25 multiplied by volume of that steel rod. Volume of that steel rod is pi by 4 into d square into L. Pi by 4 into d is 40 square into L is 6000. Length of that steel rod. Change in volume is 15,000.5 mm cube. For that steel rod of length 6 meter, diameter 40 mm and tensile axial force 1000 kilonewton, we get change in length 23.87 mm, change in diameter 9.95 into 10 raised to minus 4 mm, change in volume 15,000.5 mm cube. Thank you very much.